Okay, this video is explaining the backside of the notes on 11.3, starting with this first example on appropriate measures. This context talks about police officer recording speeds of 30 motorists and writing that data here. So as you can see, we have people that are going 32 miles an hour, 53, 56, so on. What we did here is we created a frequency table using this interval, starting with this interval, 31 to 35. That interval has a size of 5 because if you count the numbers that are between or including 31, 32, 33, 34, 35, that's 5 different numbers. So we created intervals that are that exact same size of 5 different numbers. If you look at the next interval, you count 36, 37, 38, 39, 40, that's also 5. Okay. Once we created the intervals, we crossed off that number and put a tally mark. So 32 belongs right here. Okay. And then separately, we did that for all of them. I just wrote the values off to the right over here. Okay. We created a histogram from that using these intervals. So as you can see, we have 31 to 35. I included that here. We put the other intervals as well. We put bars that are the same height or frequency as the frequency table off to the left. Okay. We did this so that we can see the distribution. I mean, you can still see the distribution from here, or we don't have that many numbers over here, but then we've got bigger numbers over here. So we can tell that it's skewed left. So we put skewed left right here. Now, when it's skewed left, there's some things that we have to consider. When it's skewed, we use the median to describe the center. We use a 5-number summary to describe the variation. So that's what we put here. Median for the center, 5-number summary to describe the spread. But, so the median, if you look at the middle number, it would actually line in between these two intervals. So it tells us that, right, the median is between 50 to 51. Let's say 50. Now, if the speed limit is 45, what can we say? We can say that most of the drivers were speeding. Okay. Now, separately from there, going to the next example, this talks about how many emojis people that identify as female or male are using. So we already have the histogram there. We're just describing it. For females, this is symmetric. And when something is symmetric, we use the mean and the standard deviation to describe it. So that's what I'm putting here. For the center, C, we use the mean. For the spread, we use the standard deviation. For male, it was skewed right, tail pointing to the right. So we would use the median for the center and the 5-number summary for the spread. Now, the median is 30 to 39, right? For this, they're equal. All right, have a good day. And then for measure for the skewedness, since it's skewed to the right, it pulls the median closer to the right, whereas this should say median. Okay. And essentially what we can say is that it's in this interval here, 10 to 19. But if the center for female is around 30 emojis and the center for male is around 10, we can say that female students, or those that identify, are more likely to use emojis. Okay? And then the last example, we wanted to create a box plot to describe the number of shoes that people own. And in order to create a box plot, you need the 5-number summary: minimum, first quartile, median, third quartile, and maximum. So we did this for women. So the minimum is 5. The maximum is 24. The first quartile is 12. Median is 14. And the third quartile is 17. We want the same thing through men right here. Okay. And then what we said is women are generally own more shoes than men because it's further along on the number line to the right. The mean for women, which is right here, is 14, is twice the median for men. The median for men, since this is skewed right, is 7. So 14 is double 7. And we also said that more variability for women because this is wider in general compared to men. So that spread is more spread out. Okay.